Alright, for this particular problem, you have to, if you're not allowed to use a calculator in the exam, all you have to do is just copy the 15, whatever this number is, and if by chance you have a denominator with, say, 1000, you know that there are three zeros. Just write 15 here, the number here, and then we all know that the decimal point for every whole number is always here. And because it's division, you move to the left, so 1, 2, 3. So that's technically 15 over 1000 is 0.015. And if you want to move it to convert this value into scientific notation, you would want to see my green writing. So 1, 2, move the decimal point. If the scientific notation is supposed to be rounded off to two significant figures, what you're seeing right now is what I did was place a decimal point in between 1 and 5, so that's 1.5. And for the green highlight, 1, 2, it's we have two zeros going to the right, and that would be times 10 raised to negative 2. Say that the zeros went to the left, and that's supposed to be positive, but in this case it's negative because as you can see, we moved the decimal point to the right, so they're all connected. Now this is another special problem. You won't be seeing this usually, but it's not in the metric system. You only most likely you'll be encountering m, l, and g, meters, liters, grams. But for the SI unit of second, there's a good chance that you'll seldom experience problems related to it. But yeah, we'll be solving this. So GY in the context of this problem is called giga year, and giga is above MB, mega year, and then next is kilo year, there's one formula that you have to take note of. I showed it earlier. It's this: 1 year is equal to 3.156 times 107 seconds. Whether you like it or not, there's a good chance that this formula won't be provided in the test, so better memorize. 3.156 times 107 s. Now, what you want to do with that value is convert giga years to 14 giga years to years. So kilo, hecto-year, deci-year, and then your old-fashioned year. Alright, so from giga year, count going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 zeros, and we can now make the fraction. So 1 giga year, and then we have 9 zeros, so 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. So basically there's 1 billion seconds in a single giga year. We cancel the giga year unit, and 14 times 1 billion is basically 14 billion. We write it in a shortcut, so that's 14 times 10, and just count how many zeros there are, which is basically 9. So 14 times 10 raised to 9 seconds. That's already the answer. Let me double check though. I know I can make mistakes, but I'm trying to keep it to a minimum. Alright, since a while ago, we are supposed to, there's a rule that, um, the rule for these kinds of problems, we have to convert our final answer into a scientific notation with two significant figures. So what we have right now is, I think it's okay, but there's another way to word this. We know that this is 14. The decimal point is invisible, located after 4. If we move it in between 1 and 4, it would affect the exponent 9. Basically, we'll be having 10 raised to 8, if I'm not mistaken. Moving to the left will decrease the exponent, I think. Never mind. Increase. So 1.4 times 10 raised to 10 seconds. These are basically the same. That's gonna take some time to digest, but yeah. Move to the left, add, move to the right, minus. Okay. I'll be demonstrating two more problems that are, never mind, not two more problems. I'll be speaking until we finish this problem. These are gonna be a little difficult if I don't speak. So let's list again the metric system. So kilometer, hectometer, decameter, meter. Kilometer to meter, 1, 2, 3. So we have 3 zeros. 1 kilometer squared over 1. So how many meters are there in 1 kilometer? We have 1000. But this is squared, so naturally this entire thing is under a squared, an exponent 2. So yeah, that's one detail that you'll have to never ignore, otherwise your entire solution could be wrong starting from that very point. There's a difference between dealing with problems with just an exponent of 1 or no exponent at all compared to ones with raised to 2 or even raised to 3. Units, usually meter, the family of meter. We all know that liter is not an SI unit, it's only derived. That's why we have meter cube. And yeah, more on that later in this particular problem, as well as this one. I'll be introducing you 3 formulas that will come as useful for you to memorize and utilize. So 1000, let's make that 1 million, and then meters squared. Actually, this is the answer. If you want to convert it to scientific notation under rounding it off to two significant figures, just write 1.0 times 10 raised to, how many zeros are there? We have 6. Let me double check just to be safe. Yep, I think this is the same problem that we just solved. This is what I was talking about earlier. This was my initial solution. I thought that I was correct, but I didn't distribute the raised to 2 to 1000. So what happened? I got a wrong answer. The answer isn't supposed to be 1000 meters squared. supposed to be 1 million, or 1000 raised to 2 meters squared. Let's move on to the next. So meter, decimeter, centimeter. Meter to centimeter, we have 2 zeros total. 1 meter squared over 1. Question is, how many centimeters are there in 1 meter? You don't really have to mention the square. That makes no difference in this regard. So 2 zeros, so that's 100 centimeters squared. Don't forget the squared for the unit, for the number itself, 100. So cancel the initial unit and bring in the final unit we're after. And then 100 raised to 2, that makes 1, 2, 3, 4, 10,000 centimeters squared. That is the final answer. Or if you want to convert it to our favorite format, scientific notation under 2 sig fig, 1.0 again. Say if you want our answer to be in 3 significant figures, just add another 0. If you want our answer to be rounded off to 1 significant figure, just write 1. And then everything else is still the same. But for now, it's still 2 significant figures, so we'll place it as 1.0. What did I get the exponent for? Count the zeros. You get the exponent. Double check. Yep, so far so good. Alright, this time we're no longer dealing with problems with the exponent squared. This time we're involving cube. This is where it gets interesting. I should spoil the formula now. 1 meter cube is equal to 1000 liters. 1 liter is equal to 1000 centimeter cube. 1 centimeter cube is equal to 1 milliliter. So this is the bridge between meters and volume. In the SI unit, the list of SI units, which are basically 7, you won't be finding anything that's associated with volume, except for the closest would be meter. The only thing that would be utilized is meter. So yeah, might as well memorize this as well as the entire metric system. Kind of exaggerated the amount of things that you have to memorize, but yeah, all up to you, all up to what you're supposed to memorize. We have apothecaries measurements, liquid and solid. Would be beneficial also for you to memorize, just in case an exam doesn't provide any of those information, and in that regard you won't be screwed. Anyways, back to the problem. We have meter, decimeter, centimeter, millimeter. Meter, 1, 2, 3. We have 3 zeros. 1 meter cube over 1 fraction. 1 meter cube. We have 3 zeros, so 1, 2, 3. Millimeter cube. And then don't forget the same exponent for the number 1000. Cancel the old unit and bring in what's new. So how am I able to write 3 sets of 3 zeros? Well, you just copy the 3 zeros and write it how many times? Whatever that number exponent is. So that's 3 times. So that's the final answer. To write it in exponent in scientific notation, we have 369, exponent of 9 millimeter cube. I think this is the same thing that we did. 1 meter cube to millimeter cube is 10 raised to 9. Yeah, they're the same. Alright, we'll be dealing with converting meter cubes to volume and vice versa, probably. No, we'll be converting from meter cube to liters. That's the general idea. From liters to meter cube, maybe not. I'm afraid not. Anyways, remember these? We'll be needing them. So 200 centimeter cube. You want to convert this to liters. Alright, centimeter cube. What's the appropriate thing to do? What's the appropriate formula? It's this one. Why? Does have the centimeter cube. But I do have another way. There's another way. You could use the formula below. So place the centimeter cube here and 1 ml over here. As simple as that. Cancel the old term, and 200 times 1 is still 200, and then ml. That's the final answer. So it just proves that 1 centimeter cube is equal to 1 ml. So I hope you can see the analogy. Let's try out 1 kilometer cube to liters. So 1 kilometer cube. First things first, we all know that kilometer cube is, well, kilometer is not recognized in any of these three formulas that I've given you. Or not formulas, conversion units. That's a better term. So our plan is to convert kilometer cube to meter cube. So let me ask you. So this is kilometer, we have hectometer, decameter, and meter. We will be moving our way down. So 1, 2, 3. 3 zeros, so 1, 2, 3. And then meter cube. So 1000 meter cube. Almost forgot the exponent for 1000. 1 0 0 0 0 0 0 0 0 meter cube. So that's a good start. Now we'll convert it. We'll have to convert it to liters. How do we do that? Well, just write the entire thing again. Over 1 times we'll be using the formula above, I mean the conversion unit above. It's the most appropriate since you can write 1 meter cube here. You can cancel the units afterwards and you have 1000 liters above. This is the final unit that we're after. So cancel terms. We have 1 billion and we add 3 more zeros. So you know what, let's not write the whole value anymore. We'll just write it in scientific notation. It's gonna save a lot of time. a lot of writing of zeros. So 3, 6, 9, 12 zeros in total, so that's gonna be the number of our exponent. And liters, of course. I bet that's the final answer. 1 kilometer cubed to liters. Where is that? There it is. 1 times 10 raised to 12. They're the same, by the way. This one's written in two, it's rounded off in two significant figures. This one is the answer if the scientific notation is only to be rounded off into one significant figure. Final question. We have kilometer, hectometer, decameter, meter, and then for hour we have, well, there's another conversion unit that you'll have to memorize. It's fairly easy. We all know that in 1 minute we have 60 seconds. In 1 hour we have 60 minutes. How many seconds are there in 60 minutes, or in other words 1 hour? We have 3,600 seconds, which is basically 60 times 60. So yeah, memorize that. So write kilometer, 100 kilometer over 1 hour. 4 kilometer, 1 kilometer there. Convert it to meter, so 1, 2, 3. 3 zeros, so that's 1,000 meters. For 1 hour, we put 1 hour here, and our final value, our final unit for time is supposed to be in seconds. How many seconds are there in 1 hour? 3,600 seconds. Cancel the old units, and we're left with meter per second. Now start multiplying. Just copy the zeros. 1, 2, 3. That's 100,000 over 3,600. I think there's a trick that we can cancel these zeros. So we have 1,000 over 36, 500 over 18, 250 over 9, 250 over 9. Alright, that's it. We'll be using the calculator now. So in scientific notation, this is 2.8 times 10 raised to 1. This is the final answer, 2.8 times 10 raised to 1. So yeah, my answer here is technically still the same, but this is rounded off into 3 significant figures. As you can see, we have 2, 7, and 8. If you're not familiar yet about significant figures, I'll be making another video regarding it. But for now, we're able to accomplish the topic on metric unit conversion. And yeah, I'll see you in the next one. Peace.